A digital voltmeter uses an ideal 3-bit analog to digital converter to display voltage measurements on the screen. If the nominal range of the analog to digital converter is 0 to 10 volts, what is the expected reading when measuring an exactly 3-volt source? So basically, analog to digital conversion, in that process, some information will be lost since analog is continuous while digital is discrete. And basically, yes, some information will be lost because of that. And they're asking us if the nominal range of the analog to digital converter is 0 to 10 volts, what is the expected reading when measuring an exactly 3-volt source? Um, First, we have to uh, familiarize ourselves with a few terms. Namely, these terms are quantization interval, integer output code, and corresponding voltage reading. So basically, the quantization interval is like for an m-bit ADC with input range V minimum voltage to maximum voltage. The quantization interval is the maximum voltage minus minimum voltage over 2 to the power of n. And this is the voltage width of one code, which is the smallest input voltage change that increases the digital output by 1. Now, let's talk about the integer digital output, which is the ADC converts an analog input voltage Vn into a digital integer code D according to D equals V minus V min over the quantization interval, where D is an integer in the range 0 less than or equal to D less than or equal to 2n minus 1. And this means rounding down. It means taking the floor or something. And this is the quantization step. So corresponding voltage reading, analog value represented by code. Once you have the integer code D, the ADC or DAC interprets it as representing the voltage. V quantized equals V minimum plus D times the quantization interval. Sometimes to approximate the midpoint of each quantization bin, you'll see V quantized mid equals V min plus D plus 1/2 times the quantization interval. This is the analog voltage reconstructed from the integer output. So here are some examples. And let's see graphically what it means. So basically, this is a quantization interval graph. So basically, um, it looks something like this. We convert a continuous graph into discrete. And this is quantization. And so let's go back to the problem for a moment. And so first we have a few key quantities we want to calculate. Um, one of those quantities is the voltage reading, which is V equals OQ. And from V equals OQ, we have two quantities we need to calculate. One of them is O for the integer output and Q for the quantization interval. The integer output is O and its quant is round uh Vn over Q. And basically we have to find what Q is now, the quantization interval. And it's going to be the V max, the maximum voltage, minus V min over uh 2 to the power of n. So from here we can first calculate Q and O, and then we can plug them into the voltage equation. So for O we have it's equal to round Vn over Q, so it's equal to round Vn, which is actually let me see, what is it? Vn. So Vn is actually 3 volts. So we will have 3 over Q. And then what is Q? Again, Q is the quantization interval. And it's going to be calculated from Vmax minus Vmin over 2 to the power of n. And n is the number of bits. So Vmax is going to be 10 volts. Vmin is going to be equal to 0 volts. And then n is going to be 3. So we have 10 over 8, which is 5 over 4. So we can plug it into in for Q over here. And then we have that it's equal to round 3 over 5 over 4. And this is equal to 12 over 5. Which is equal to 2 and 2/5 volts. And this is actually not all that we have to do. Um, we have to plug it in for this. So V is equal to 12 over 5 times 5 over 4. And this is equal to 12 over 4. I believe, wait, hold on. Let me see if I did that correctly. Actually, I did it wrong. We have to round this value actually. The 2 times the 2 and 2/5. So this rounds to what is 2 and 2/5? First of all, we have to know what that is. So 2 and 2/5. So uh 2/5 is actually 0.4. So this value is equal to 2.4. And basically we have 2.4 times 5 over 4. And this value is equal to uh, 2.4 times 5 divided by oh wait, sorry, I still forgot to round. So rounding 2.4, it rounds to 2. So 2 times 5 over 4 is equal to 2 times 5 divided by 4. So this is equal to 2.5. Or 5 over 2, which is equal to 2 and 1/2. Yeah, and that is the correct answer marked over here. Thank you guys so much for watching this video, and I'm going to post these slides afterwards.